Previously, we learned how to multiply polynomials using the distributive property. There are some special cases where we can identify some patterns to help us find the product more quickly. These patterns will also be useful when we go to factor polynomials. The first one is what we call the square of a sum. And what we mean by the square of a sum is when we have a polynomial that looks like this: x plus 2 squared. Now remember, our rules of exponents tell us that this number here, the exponent, tells us that we're using x plus 2 as a factor 2 times. So this is equivalent to x plus 2 times x plus 2. Now we can use our distributive property, or the FOIL method, to multiply out this binomial. So we have x times x, which is x squared, x times 2, which is 2x, 2 times x, which is 2x, and 2 times 2, which is 4. We can combine our like terms, and we end up with x squared plus 4x plus 4. Okay, so that's no different than we've looked at before. Let's look at what happens when we do this in general for any real numbers. So if we look at anything that has the form a plus b squared, we end up with a plus b times a plus b. Now we can use our same methods before. A times a is a squared. A times b is ab. B times a is also a times b, or b times a, but we can write it either way. And b times b is b squared. If we combine our like terms, we end up with a squared plus 2ab plus b squared. Now, we know that anytime we multiply out two binomials that look like this, we're going to end up with this trinomial. So our formula for square of a sum looks like this. Anything in the form a plus b squared is equal to a squared plus 2ab plus b squared. So let's look at an example using this. So here's our formula up here at the top, and we have example 1. We will do x plus 7 squared. Now we could just multiply this out like we always have, but we found a formula that should work in every case. So we're going to call this our a, and 7 will be our b. So what we should end up with, following our pattern, is that a squared should be x squared plus 2 times a, which is x, times b, which is 7, plus 7 squared. All I did was substitute in x for a and 7 for b into this formula up here, into this formula. So now I can simplify this, and I get x squared. 2 times 7 is 14, so I get 14x plus 49. Let's look at another example. So if we have 4x plus 2 squared, using our formula above, we're going to call 4x a, and we're going to call 2 b. So again, we're going to refer up here. So our first term should be a squared. So that's going to be 4x squared. So all of 4x is that as being squared. Our second term is 2 times a times b. So 2 times 4x times 2. And our last term is b squared. So plus 2 squared. So now we can simplify all that. Remember our properties of exponents. So 4x squared means 4x is used as a factor 2 times. So that's 4x times 4x, which is 16x squared, plus 2 times 4 times 2. 2 times 4 is 8. 8 times 2 is 16. 16x for our second term. And our last term becomes 4 squared, or 2 squared, which is 4. So this is our final simplified polynomial. Now, I encourage you to go ahead now and look at the problems under example 1 on your worksheet, and go ahead and try those problems, and then check your solutions. The answers are provided to all those problems, so make sure you check your answers when you are finished.